Hello students, now we will have a look at the question from GATE 2020 EC paper, especially from network analysis subject. Here the question is, in the given circuit, the two-port network has the impedance matrix 40, 60, 60 and 120, these are the Z parameters. The value of ZL for which maximum power is transferred to the load is. So, what is the condition for which maximum power is transferred? If you observe, this question is a mix of two-port networks and theorem, that too especially maximum power transfer theorem. If you could recollect, maximum power is going to get transferred from source to load when your load impedance is equals to Thevenin's impedance. See, this is a simple DC circuit, so you need not think of conjugate and all. So, here it is written as ZL, it could be ZL or RL, both are one and same. When load is variable, the value of ZL should be equals to ZTH in order to transfer maximum power. Now the next question, how to calculate ZTH of this circuit? It's a standard circuit, it's a Z parameter model, but the only thing is there is a resistor connected in series with the input port. Now, when a resistor is connected in series with an input port of a Z parameter model, and if you want to calculate its ZTH, therefore it can be given by your ZTH is equals to Z22 minus Z12 Z21 divided by Z11 plus R. So, this is the direct expression. So, now what is Z22? 120 minus what is Z12? 60, Z21 also 60 divided by 40 plus 10. So, that becomes 120 minus 3600 by 50. So, that comes to be 48 ohms. So, what is your ZTH? 48 ohms. Now, what must be the value of ZL such that maximum power gets transferred? That should be equal to 48 ohms. Now, the next question, how did I landed at this expression directly? Might be a worrying thing for you. Now, I will give you a quick simple solution for this expression. Let me clear this. I have taken the same circuit here. Can you please recollect the two-port network parameter equations? What are the two-port network parameter equations? Your V1 equals to Z11 I1 plus Z12 I2. But here your V1 is not the supply voltage. So, therefore, V1 I can write it as 120 minus 10 I1 is equals to Z11 I1 plus Z12 I2. Now, what is your equation is 120, send it that side. So, I am taking I1 common, so that becomes Z11 plus 10 into I1 plus Z12 I2. So, this is equation 1. Now, what is the second equation? That is the output port equation, that is V2 equals to Z21 I1 plus Z22 I2. So, these are the two-port network parameter equations, Z parameter and Z parameter equations, input port and output port, which you are very familiar with. But now, what is the question? Our question is, what must be the value of your ZL? As I said, your ZL must be equal to ZTH. Now, the next question, let us calculate ZTH. How to calculate ZTH? Now, ZTH can be calculated in two styles. One is by our traditional method, where remove the load, open circuit the terminals and deactivate all energy sources and look from the open circuited terminals point of view, and the equivalent resistance is what your ZTH. By network reduction technique you do that, but do you know what is present inside this box? You have no clue. Here comes another method, second method, simple and interesting method, that is test voltage or test current method. For example, if I give you a small resistor and I remove color coding on it, how do you measure the value of this resistor? Simply you are going to take a multimeter and connect it across those terminals. What exactly do you think that multimeter is doing? It is applying some voltage across it and it is measuring some current through it. The ratio of voltage across it by current through it is nothing but what? The resistance offered by it, right? So, the same thing I am going to do it here. Step number 1, remove the load. Assume that this load is open, right? Okay, I will redraw the circuit. Remove the load, open circuit the terminals and look from this side. So, this impedance is what here? ZTH. Sorry, here there is a 10 ohm resistor, right? Now, Network reduction technique is not possible because I don't know what is present inside this box. And the second and the most easiest option is, let us connect some voltage across these two terminals and find out the current, or let us connect some current source of any value and find out the voltage. Now let me connect some voltage source of any value. So let that voltage source be V and let the current be I. Let us say this is AB. Now what do you think your ZTH is nothing but what? ZAB, which is equals to VAB by IAB, right? Now the next question, can you guess what is your VAB? Your VAB is nothing but what? V2. Am I correct? Your VAB is nothing but what? V2 now. Next, what do you think your IAB is nothing but what? Your IAB is nothing but what? Your I2. So, if you want to calculate ZTH, all you need to do is take out the ratio of V2 by I2 in this circuit. So, this is your V2 and this is your I2. So, the ratio of V2 by I2 is nothing but what? Your ZTH, right? So, please select such an equation where you have V2 and I2. So, where do you have? That is equation number 2. But the only issue is you have a term called I1. No problem. Can't you write this I1 in terms of I2? I can write it. So, can you tell me what do you think I1 is? 120 minus Z12 I2 whole divided by Z11 plus 10, right? So, this is what your I1. Now, please substitute. So, what is your, let me erase this portion. So, your V2 is equals to Z21 into I1. What is I1? 120 minus Z12 I2 whole divided by Z11 plus 10 plus Z22 I2. Alright. Now, let us simplify this. That is, multiply it inside. So, what are you going to get? Z21 into 120 minus Z12 I2 whole divided by Z11 plus 10 plus Z22 I2. That is Z21 into 120 by Z11 plus 10 minus Z21 Z12 by Z11 plus 10 into I2 plus Z22 I2. So, can I take I2 common? So, if I can take I2 common, so for this whole term, what is going to get added up? Plus Z22 into I2. This is what your V2 now, right? So, V2 is equals to this term minus Z21 Z12 by Z11 plus 10 plus Z22. So, I have taken I2 common. Fine. I hope it's clear. So, now I am erasing this portion. Simple. I solved that second equation where I can find only V2s and only I2. Now, let us get back. As I said, let's not forget our major target. Our ultimate target is to calculate what? ZTH, which is nothing but what? The ratio of V2 by I2. I'll do one thing. Can I replace this whole circuit with an equivalent circuit called Thevenin's equivalent circuit? If you replace this whole circuit with an equivalent circuit called Thevenin's equivalent circuit, it looks something like this. So, this becomes VTH and this becomes ZTH and this is your V2 and here this is your I2, right? This whole portion, okay? Now, the current is flowing in this direction. Now, from this, can you please tell me what is the relation V2 is equals to? Can I say VTH plus I into ZTH? To be precise, your I or I2 all are one and same, right? So, let me write it as I2 and I2. Now V2 is equals to VTH plus I2 into ZTH. Now please compare the equations. If you compare the equations, what are you going to get here? V2 and V2, right? Next VTH and this is VTH. Okay. Now if you could send minus inside, what are you going to get? You are going to get it as what? I shall erase this portion. If you send minus inside, what are you going to get? You are going to get as this whole term, I will simply call it as, can I call this as VTH? So if you could compare the coefficients, this whole term I can call it as VTH. So that is VTH plus. So here I am sending this minus inside, so that becomes obviously plus Z22 minus Z21 Z12 whole divided by Z11 plus 10 into your I2, right. So if you could compare, so this is VTH, I2 and I2. So this whole term is nothing but what? ZTH, right. So this is how I directly wrote the formula and this is the proof. Now tell me, what is your ZTH is equals to? Z22 minus Z12 Z21 divided by Z11 plus 10. So if you could substitute the values again. So what is Z22? 120 minus, what is your Z12 into Z21? 60 into 60, 3600 divided by Z11 plus 10, that is 40 plus 10, 50. So 120 minus 3600 by 50, so that turns out to be 48 ohms. Okay. So that's about how to calculate ZTH.